Welcome to the Deep Dive. Today, we're jumping into something that honestly still sounds a bit like science fiction, quantum technologies.
Right. But it's becoming very real, very fast.
Exactly. So our mission today is to get past the buzzwords. What does quantum actually mean for you right now and down the line?
Well, think about it this way. The first quantum revolution gave us things like lasers, MRI, GPS, stuff we use daily.
Okay, standard tech now.
Yeah, but this second quantum revolution, it's different. We're now directly grabbing hold of those weird quantum particle behaviors, the really strange stuff at the atomic level.
To build completely new things.
Precisely, entirely new kinds of technology.
Okay, let's unpack that.
Sure.
What are these quantum technologies? How do they even work?
So at the heart of it, they use quantum phenomena. Things like superposition, where a particle is in multiple states at once, kind of like a coin spinning, neither heads nor tails yet.
Right, that weirdness.
And entanglement, where particles get linked, mysteriously connected no matter the distance. These let qubits, quantum bits, hold vastly more information than the simple zeros and ones of classical bits.
More information potential. Got it.
And this whole revolution is really unfolding across three main branches: sensing, computing, and communication.
Fascinating. Okay, how does that translate? Let's start with sensing. Quantum sensing sounds very high-tech.
It is, but it's also the most mature part. It's actually already touching your life. Think atomic clocks.
GPS and stuff?
Exactly. They're the reason GPS is so accurate. Same for telecommunications timing. Or quantum magnetometers, they can sense magnetic fields like 1,000,000 times weaker than normal ones.
1,000,000 times. Wow.
Yeah. Super vital for medical imaging, like getting much clearer MRI scans. The sensitivity is it unlocks new possibilities.
Incredible precision. Okay, but the one that really grabs headlines, maybe the most mind-bending, is quantum computing. What's the real story there? Is it overhyped?
Well, it's definitely got hype, but there's substance. Look, quantum computers aren't going to replace your phone or laptop. Not the idea.
Okay, good to know.
They're designed for specific, incredibly complex problems. Problems that even the biggest supercomputers today just choke on. This is what we call quantum advantage.
Tackling the impossible problems, then. Like what?
Think simulating molecules for discovering new drugs, or designing revolutionary new materials atom by atom, or maybe optimizing, say, global shipping routes. Massively complex calculations.
So fundamentally changing what we can calculate. What about the progress? Is it still mostly, theoretical lab stuff?
Oh, far from it now. 2024 saw some major steps. We actually saw genuine logical qubits demonstrated. These are like error-corrected qubits that are much more stable.
Error correction is key, right?
Absolutely. And hitting 99.9% fidelity accuracy in operations between two qubits, that's huge for building towards fault-tolerant machines.
Okay, real hardware improvements.
Oh, definitely. And the global race is, intense. The U.S. is strong on the variety of quantum processors and research quality. China's leading in patent filings and really pushing quantum communications research.
The money's pouring in.
Billions. Startup investment hit $2 billion last year alone. Countries like China are talking about investing up to $15 billion. It's serious commitment.
That kind of power, though, it raises security questions. Which I guess leads us to the third area, quantum communication.
Exactly. That's where quantum key distribution, or QKD, comes in. It uses quantum physics to create cryptographic keys that are theoretically unhackable.
Unhackable? How?
Because if anyone tries to eavesdrop, the very act of measuring the quantum state disturbs it, revealing the spy. It's built-in security.
Okay, that's crucial, especially with this Q-Day idea I keep hearing about.
Right. Q-Day is the hypothetical point when a powerful quantum computer could break today's standard encryption. So QKD is about building the post-quantum security infrastructure before that happens. Test networks are already up in the U.S. and Europe.
Building the secure future internet, basically.
Mm-hmm.
So stepping back from the tech, what are the bigger picture implications for, society?
It's huge, potentially. On the one hand, amazing possibilities, new drugs, climate change solutions through better modeling, super efficient logistics.
The upside sounds massive.
It really does. But there are challenges too. Privacy concerns, for example, with super sensitive quantum sensors, and the risk of a new digital divide.
How so?
Well, if the infrastructure for, say, a quantum internet is incredibly expensive, Will it only be available to wealthy nations? That could deepen inequalities.
That's a really important point. So for you listening, digesting all this, what does quantum readiness actually mean? What should we be doing?
Yeah, quantum readiness is becoming a key concept. For you, it means things like building up data skills. Quantum relies heavily on data. It means keeping an eye on these breakthroughs because they are accelerating.
Staying informed.
And just starting to grasp how this abstract sounding quantum world is going to filter down and shape, well, potentially everything. From personalized AI tutors in the future to global economics and even politics.
It really feels like the shift from asking if quantum will have a big impact to when is happening right now.
Absolutely. The pace of breakthroughs is just remarkable. It's definitely a field that needs our attention.
So here's something to think about. How will you get ready for a world where these strange, counterintuitive quantum rules become part of the everyday fabric, influencing your life and our whole connected planet?